Consider this question. A variable line L is drawn through origin to meet these two lines. In fact, these two lines are parallel at points A and B respectively. Now, point P is taken on L such that 2 upon OP is equal to 1 upon OA plus 1 upon OB. Then we have to find locus of point P. Okay, we are drawing this diagram with reference axis because here origin is point of reference and two lines which are parallel, which are simple to plot on axis. Now lines are parallel like this. This line is y minus x minus 10 is equal to 0, and this is y minus x minus 20 is equal to 0. Now we are drawing lines from origin, which is variable because slope is not fixed. We can draw infinite lines passing through origin. Now this line cuts these lines at A and B respectively. There are infinite such lines. Now we have to find locus of point P. Suppose P is somewhere here, maybe somewhere else, but suppose P is here on this line L such that 2 upon OP is equal to 1 upon OA plus 1 upon OB. Then in that case we have to find locus of P. Okay, समझ में आ रहा है यहाँ पे लोकस कैसे फॉर्म होगा? जैसे हमने कोई एक लाइन रैंडमली इस तरह से ड्रॉ किया तो ये ए एंड बी पॉइंट आया. अब हम इस लाइन के ऊपर पॉइंट पी सिलेक्ट करेंगे जिससे ये रिलेशन सेटिस्फाई हो, तो हमें यहाँ पे पी मिलेगा. फिर से हम कोई एक दूसरा लाइन ड्रॉ करेंगे तो हमें यहाँ पे मिलेगा ए एंड बी. देन वी विल गेट पॉइंट पी ऑन दिस लाइन विच सेटिस्फाई दिस रिलेशन. इस तरह से हमें कितने पॉइंट्स मिलेंगे? P इनफाइनाइट. उन सभी पॉइंट्स को ज्वाइन करेंगे तो क्या बनेगा? एक कर्व. हमें उस कर्व का इक्वेशन निकालना है, यानी कि उस लोकस का इक्वेशन निकालना है. ओके, जिस पॉइंट का लोकस निकालना है उसको अज्यूम कर लेते हैं सपोज h कॉमा के. इट मीन्स वी हैव टू नाउ फाइंड रिलेशन फॉर h कॉमा के. फर्दर जब भी किसी पॉइंट से निकलता हुआ लाइन आगे जाके एक या ज्यादा लाइंस को इंटरसेक्ट कर रहा है तो हमेशा ऐसे केसेस में हम यूज करते हैं पैरामेट्रिक फॉर्म ऑफ स्ट्रेट लाइन. उसका रीजन क्या है? क्योंकि यहाँ पे डिस्टेंस OA एंड OB इन्वॉल्व है, तो पैरामेट्रिक फॉर्म से हम इन डिस्टेंस को आसानी से यूज कर सकते हैं. Okay, how we get distance OA? Suppose OA distance is R1. Now from this R1 we can find coordinates of point A. Now suppose this angle is theta. Now theta is not fixed because line is variable. Then coordinates of point A will be R1 cos theta comma R1 sin theta. Now we can get R1 by putting point A in the equation of this line because A lies on this line. It will satisfy this equation. So we have R1 sin theta minus R1 cos theta minus 10 is equal to 0, or R1 is equal to 10 upon sin theta minus cos theta. Now what is R1? R1 is OA. So we got OA 10 upon sin theta minus cos theta. Similarly, consider OB is equal to R2. Then coordinates of point B are R2 cos theta comma R2 sin theta. Now B lies on this straight line. It will satisfy this equation. So we have R2 sin theta minus R2 cos theta minus 20 is equal to 0. Hence R2 is equal to 20 upon sin theta minus cos theta, which is distance OB. Now we got distance OA and OB, and we have a relation 2 upon OP is equal to 1 upon OA plus 1 upon OB. Then put the values of OA and OB in this relation. So we have 2 upon OP is equal to 1 upon OA will be what? Sin theta minus cos theta upon 10 plus this is sin theta minus cos theta by 20. Now we have to find locus of point P. Suppose this distance OP is R, small r, then coordinates of point P will be R cos theta comma R sin theta, which are in fact H comma K. So we have H is R cos theta and K is R sin theta. Then this is 2 upon R. Then 2 is equal to R sin theta. Okay, in fact, let's first of all simplify this RHS. If you take LCM, which is 20, so we have 2 sin plus sin, that is 3 sin theta minus 3 cos theta upon 20. This implies 2 is equal to, or in fact 40 is equal to 3 times R sin theta minus R cos theta. And what is R sin theta? From this comparison, that is K, and what is R cos theta? This is H. So we got locus of point P, which is y minus x is equal to 40 by 3, which is in fact straight line. One concept in this equation: when we have a variable line passing through any given point which meets further number of lines, then always use parametric form. If distances are involved, like here distances OA and OB are involved, in this case the same equation, if we change the condition OP square is equal to OA multiplied by OB, then find locus of point P. Now OA and OB are same. OP is taken R, then we have R square is equal to OA multiplied by OB. This is 10 upon sin theta minus cos theta. This is 20 upon sin theta minus cos theta. So we have R square multiplied by sin theta minus cos theta square is equal to 200, or R sin theta minus R cos theta square is equal to 200. Now replace these values by K and H respectively. So locus is K minus H square is equal to 200, or y minus x square is equal to 200. Now this is pair of straight line.